This is going to be part 2 to dynamic equilibrium, and today we're going to be focusing on Le Chatelier's principle. Le Chatelier's principle states that if a stress is added to a reaction in equilibrium, then that reaction will take the steps to counteract that stress. Basically, there are just multiple things that you can do to a reaction, and we can use Le Chatelier's principle to predict how the reaction will react to that stress. The first factor that affects equilibrium that we'll be looking at is temperature changes. So if we add heat to a reaction equilibrium, then that reaction is going to try to remove that heat. It's going to try to decrease the heat in the reaction. And same things vice versa. If we decrease the heat in a reaction, then the reaction will try to increase the heat. So basically, the reaction is going to respond in a way to counteract what was done to it. We say that the reaction is going to shift to remove the heat. Now, let's take a look at some reactions so that we can determine which way certain reactions will shift. Let's first take a look at this top reaction. We can see that the heat is on the reactant side, so therefore it is an endothermic reaction. If we increase the heat, then we learn that the reaction will try to remove it, right? So therefore, the change is that the equilibrium will shift to the right, because it will produce more products using up more of the reactants, which is using up more of the heat, so therefore there will be less heat. In the bottom reaction, if we increase the heat, then the reaction will shift to the left. That's because it's going to use more of these products up to make these reactants so that more of the heat gets used up to take away that heat that was added. It's going to try to counteract it. That's all Le Chatelier's principle is. And now, same thing's going to happen vice versa. If we decrease the heat on that top reaction, then the equilibrium is going to shift to the left instead. Well, why is that? Because we took away some of this heat, so the reaction wants to add more of it in. Therefore, it's going to use up this product to create more reactants, which in turn creates more heat. It's trying to make more heat that we just took away. On the bottom reaction, if we decrease it, then it's going to shift to the right, because we want to make more heat. The second thing that we'll look at that can affect the equilibrium is the pressure. Now, we must keep in mind that this only affects gases. And this is because liquids, solids, or solutions, aqueous solutions, you can't change the pressure of it, right? You can't compress a liquid, you can't compress a solid, but you can compress gases. So that's why we must remember that this factor only applies to gases. Now, the way that this one works is that if we increase the pressure, then we decrease the volume. So, Le Chatelier's principle states that if we increase the pressure, then the reaction is going to shift to the side with fewer moles of gas. So, let's take a look at this reaction. We can see that on the reactant side, there is 1 mole. On the product side, there are 2. So, using Le Chatelier's principle, we can determine that if we increase the pressure of this entire system, the equilibrium is going to shift to the left. The reverse reaction is favored. So therefore, these products are consumed, whereas these reactants are formed. And as always, you must remember that the opposite is true. So if we decrease the pressure of this bottom reaction, then the equilibrium is going to shift to the right instead. Because we learned that if we increase the pressure, it goes to the side with less moles. So that means if we decrease the pressure, it's going to the side with more moles. That means that these reactants are going to be consumed, and this product is going to be made. The next factor is concentration changes. So, Le Chatelier's principle states that if we increase the concentration of something, then that reaction is going to try to decrease the concentration of what we just added, right? Because it's going to try to counteract whatever we do to it. So let's take a look at this. We have A plus B turns into AB. If we increase the concentration of A, then the reaction is going to shift to the right. Why is that? You can probably predict why. It's because when we add more A, the reaction wants to counteract it, right? It wants to remove the A. So, therefore, it's going to shift to the right in order to use up the A that we added to form more products, right? It wants this concentration that we just increased to go back down. And as always, the opposite is true. If we decrease the concentration of A, equilibrium is going to shift to the left, because if we just removed A, the system wants to make more A. So it's going to use the products to form more reactants. Now, the final thing that we're going to look at is catalysts. Now, this is actually a trick question because catalysts don't change the equilibrium of a reaction. Okay? You actually might see this on some tests, and they're just trying to see your understanding of this. Catalysts, they do not. You must remember that catalysts do not change the position of equilibrium of a reaction, but it may help the reaction reach equilibrium faster. And as we come to the end of this video, I just want to rephrase some terminology. So if in this top reaction, we said that it shifts to the right, we can also say it like the reaction favors the products. And if in this bottom reaction we say that it shifts to the left, we say that it favors the formation of reactants. So just remember those things. They can be used interchangeably, maybe a bit tricky, but just remember these things and you'll be good.